Okay, welcome everybody to lesson 3 of our equations of linear relationships unit. Today we're going to be looking at equations in the general form. So it's just another way of writing our equation down. We looked at Y-intercept form last class. Today we're going to look at the general form. And just if in case you're wondering why do we need a new form? Well, general form, writing equations in general form allows us to graph non-functions. So if you wanted to graph a circle or some shape that looked something like that, we would be able to use the general form much better than the Y-intercept form. The Y-intercept form would not work. Okay, so the general form of the equation, all the terms are basically on one side, as you can see here, and zero is on the other side. So, just using some algebra, we can rearrange our y equation from one form to the other. So I'll show you a few examples with that. But in general, there's really nothing new that you're learning here. It's just a different way of looking at the same equation. And again, both these equations, both this style of equation and Y-intercept equation has their benefits and their drawbacks. So there's some pros and cons with both methods. Okay, so let's just go ahead and do a few examples. So here it says, convert the following equations from slope Y-intercept form, which was y equals mx plus b, where m is the slope and b is the Y-intercept, to the general form of ax plus by plus c. And then the key thing is a, b, and c have to be integers. So you can't have fractions like you can in the Y-intercept form. Okay, so the first thing I want to do is I want to get everything to the left side of the equation. So I'm going to get now it's going to be negative. Actually, the easier thing to do is to get everything to the right side of the equation, because I have more things on the right side. So all I need to do is get the y over. So I'm going to subtract y from both sides, and I'm going to end up with 0 on the left side. And then it's going to be 5x minus y minus 8. Okay, notice how I wrote this. I wrote the x term first, then the y term, and then this constant here that has no term. So if you were to to look at what a, b, and c are, well, a in this case is 5, b in this case is -1. There's that -1 that's not written there, and c is -8. So as long as they're integers, and the x term is written first, that is the general form. Okay, so those are the key things. So let's go ahead and do a couple more examples here. All right, so now we have a problem here because I have a 3 in the denominator here, and the key thing with the general form is you can't have fractions. So again, I'm going to move the y over 2/3 x here minus y plus 7, but then I'm going to multiply everything by 3 to get rid of that denominator. Well, 3 times 0 is going to end up as 0. 3 and the 3 cancel here, so I have 2x minus 3y plus 21. Okay, so all I did was manipulate it a little bit just to get rid of that denominator, because I do have to have integers for a, b, and c. Okay, last one here. So let's go ahead and do the same thing. So I'm going to have, well, the first thing I'm going to do here is I'm going to get rid of this, the 4 and the 5. So I'm going to find our lowest common multiple here, and that's going to be 20. So I'm going to multiply everything by 20, and that'll help me get rid of those denominators. So in this case, I have 20y equals -5x plus 12. And if you're not really sure why how I got this, you need to do some review when you're solving equations in your algebra. Okay, so again, now I'm going to get everything to one side. and it's going to be negative 5x minus 20y plus 12. The only problem here is that you cannot have a has to be positive. That is the one rule here. So the term on the x, your term on the x has to be positive. So how do I make this positive? Well, I can factor out a negative 1 from everything, which will make everything all the signs flipped around. And then that's actually it. That's all you do. You can just flip all the signs around, because if I take out a negative 1 and divide both sides by negative 1, 0 divided by negative 1 is going to be 0. So it's going to be positive 5x plus 20y minus 12. All right, let's move on here. So determining the slope and the y-intercept from this equation is a little bit different. Okay, unfortunately, this isn't as useful as the y-intercept form is when we're graphing, because I cannot, there is no m and there is no b. I have to manipulate it around, so in order to get the slope. So given the equation of a line in general form, the slope and the y-intercept can be found by converting the equation into the slope y-intercept form. So now we have to go back the other way around. So it says determine the slope and the y-intercept of the graph of the following lines. Okay, so again, I first have to rearrange this guy back to y-intercept form. And remember, y-intercept form should look like y equals mx plus b. So I'm going to get everything on one side and y on the other side. So let's just go ahead and do that first. So I have negative 5y here equals negative 2x minus 25. So I just got those over there. All right, now I'm going to divide everything by negative 5, and it's going to be y equals 2 over 5x plus 5. And that's it. So now I can tell my slope. There's my slope, rise over on 2 over 5, and my y-intercept. And you can easily graph this just from looking at this equation here. Okay, so there's the y-intercept at 5, and then I'm going to go up 2 and over 5. And as soon as you get your 2 points, you can graph your line. Okay, let's look at B. So again, the same thing. In order to get the slope and the y-intercept, I first need to rearrange this equation that's in general form and get it into y-intercept form. So let's shoot everything to one side and leave the y on this side. So the 2y is going to stay here. So let's get the 6x and the 15 over here. So negative 6x plus 15. And then I got to get rid of the 2. So I'm going to divide everything by 2. So it's going to be y equals negative 3 x plus 15 over 2, or 7.5. And there we go. So as soon as I get it in this form, I can clearly see that there's the y-intercept, and there's the slope, and there's the y-intercept. Okay. The line, let's look at example number 3. So the lines 3x minus 4y plus 8 equals 0. So that's the general form. And this other line, 5x minus ky minus 6 equals 0, have the same y-intercept. That's a key piece of information. Determine the value of k. Okay, we have this unknown value of k here. So I first what I need to do is, because they have the same y-intercept, I need to find the y-intercept from this equation over here. And again, I'm just going to rearrange it into y-intercept form and just look off the equation to get the y-intercept. So this is going to be 3 over 4 x plus 2. Okay, so there's my y-intercept, and because they share the y-intercept, this equation here is also going to have the same y-intercept. Okay, but let's just go ahead and just think of this a little bit more logically. The y-intercept here is 2, which means the coordinates of the y-intercept are 0, 2. Okay, because the x value is 0. So if those are my coordinates, I can just plug those in for my x and y value. That's x and that's y. So 5x minus ky minus 6 equals 0. all I need to do is substitute that for x and that for y, and then solve for k. So let's go ahead and do that. So if I put in a 0 here, that's going to be 0. So it's going to be negative k times 2 minus 6 equals 0. Negative 2k equals 6. K equals negative 3. All right. Let's keep going here. So which of the following lines are perpendicular to this line? Okay, so if I want to know if these lines are perpendicular, I need to first find the slope of this line. Well, the slope of this line is going to be, I first need to rearrange it into Y-intercept form. Let me get some room here. Let me do that again. So negative 2y equals negative 4x minus 9. And then my equation is going to be y equals 4 divided by 2 is 2x plus 9 over 2. Okay, so this is 2 over 1. That's my slope, and we're looking to see if these lines are perpendicular. So if they're going to be perpendicular, slope is going to have to be negative 1/2, because perpendicular lines have the opposite slope there, reciprocal and negative. So that's what we're looking for. So if I rearrange these guys, and I get this as the slope, then they're going to be perpendicular. Okay, so let's go ahead and work that out first. So I have 3y here equals negative 6x plus 1. Y equals negative 6 divided by 3 is going to be negative 2x plus 1. Okay, which of the following lines are perpendicular? Well, that negative 2 over 1 is not the same as that. So this line is not perpendicular. Let's go ahead and do this one. So I have 2y equals negative x plus 12. Y equals negative 1/2 x plus 6. Aha, there it is. There's a match here. There you go. So that is, those two lines are perpendicular. So myself a check mark here. Last one. This is going to be 10y equals negative 5x plus 0, which I'm not going to write down. Y equals negative 5 over 10x. Simplify that to a negative 1/2 x, and look at that, we have another match. So these lines are perpendicular to this line up here. All right, one more I think for us here. Okay, so write the equation of a line which is perpendicular to this line and has the same y-intercept as this line. All right, so we need to come up with line 1 that is perpendicular to line 2 and has the same y-intercept as this line 3. And they want us to write the answer in both forms. Okay, in y-intercept form and in general form. So a lot of algebra for us to do here. The first thing I'm going to do is I'm going to rearrange these equations into y equals mx plus b, so that I can get the y-intercept and the slope. So 5y minus equals minus 2x plus 7. Y equals negative 2 over 5. X plus 7 over 5. The only piece of information we're looking from this line is its slope, because our slope is going to be perpendicular. So there's that slope. So our slope must be 5 over 2. So I'm going to go ahead and come up with our line over here. Y equals mx plus b. Y equals, well, there's 5 over 2x. Okay, now I'm going to get the b, and I'm going to get the b from this equation over here, because it says has the same y-intercept as this equation. So again, here we go. Oops. It has y equals negative 2x plus 6. Okay, that one was pretty easy to rearrange. And there it is. That's all I'm looking for, is that 6 there. So that's going to be the y-intercept over here. All right, so then that's y-intercept form. So I'm going to rearrange this and get it into general form, which is going to be 0. Remember, you're going to get 0 on one side. and everything else on the other side. So 5 over 2x minus y plus 6. Then multiply everything by 2 to get rid of this denominator. And then we're going to be left with, let me just do it over here, 0 equals 5x minus 2y plus 12. All right, those are our two answers right there. All right. Okay, I'll leave it there. You guys can try this last example on your own here, example number 6. So if you want to get some extra practice before class, go ahead and do that one. Okay, thanks for watching and see you next time.